Alright class, welcome to Sword Science. Right now we're looking at F2, lesson 2.1, what is acceleration and deceleration. This is a concept video. We're going to be looking at what it is and the different parts of it. We're not going to be looking at how to calculate it. That's lesson 2.2. So if you're having questions on that, please go to Forces 2, lesson 2.2, what is acceleration and how do I calculate it. To wrap our minds around what acceleration is, basically I can look at this problem here. Rupert's biking up a hill at a velocity of 10 miles per hour west. When he got to the top of the hill at 5 minutes later, his velocity was 25 miles per hour west. And so did he get faster? Did he get slower? My questions that I might think about with this is, what is my difference in speed? And so I might look at, okay, well, what did he start at and what did he end at? And so I have these ideas here, and my difference in speed was 15 miles per hour. So did he go up or down? That's what I need to think about. He increased his speed. Another question I'm thinking about is, how long did it take him to get to the top of the hill, his top speed? And so to get to 25 miles per hour, it took him 5 minutes to do that. And so that's another thing that I'm thinking about with this type of problem. Also, how could I figure out the rate of change in speed each minute? That's kind of taking these two together to get question 3. And this idea of change in the rate of speed, but in our case it'll be velocity. This is all acceleration. To illustrate this concept a little bit more fully, what I did is I have a nice little graph here, whereas each box represents about 2 meters, and we're going to be looking at the rate of change of velocity, and that's what acceleration is. And so if I were to look at this thought, okay, if I was traveling at an acceleration of 2 meters per second square, or 2 meters per second squared, that basically means that for every second, I'm increasing my rate of speed by 2 meters per second. Okay, so if I look at that, my first second I traveled this speed. Okay, that's 1 second. Okay, but then let's say my next second that I'm traveling, I traveled, now that was 2 meters per second for 1, here I am after 2 seconds. I traveled 2 meters per second, 4 meters per second actually. And then if I go a third second, okay, that would be 3. I'm now going 6 meters per second. And if I go another one, that means 4 seconds later, I'm actually going 2, 4, 6, 8 meters per second. Here it was 6 meters per second. Here it was 4, and here it was 2. And if you can guess, the next one, I'm increasing another 2 meters per second. I am now at, after 5 seconds, I'm now at a speed of 10 meters per second. And so as you see, my rate of increase, or my rate of speed, has increased every second by 2 meters per second. And so that's kind of what acceleration is. It's an increase of speed. It's not a constant rate of speed, but the rate at which I get faster. As I continue thinking about acceleration, there are 2 ways that I could change my acceleration. I could both increase speed, but I can also decrease or get a negative acceleration. So we have a positive and a negative acceleration. Positive change is known as acceleration. That's one we always talk about when we're getting faster. An example of that would be positive 5 miles per hour, and I need to put brackets there, south. Now, there's also negative change in velocity, and this is a deceleration of speed, and so of velocity, and so the deceleration will be a negative value as a result. And so if I'm decelerating, that means I'm slowing down, the rate at which I slow down. And so an example of that would be a train decelerating at -8 miles per hour per minute in a west direction. Now our formula for acceleration is the final velocity minus the original velocity that I began with divided by the time it takes. So we usually look at it as FV minus OV over T. Now it's important to make sure that these are in the correct order, because if you mix them up, you're not going to know if you're accelerating or decelerating. It'll change, because if you have them in the wrong order, you won't know if it's a positive number or a negative. And so a sample unit would be miles per hour south. Okay, and you won't always use miles per hour. You'll probably also use meters per second, or meters per hour per second, or something weird like that. But what you'll see is that this is my velocity, and this is my time label. And so we also have the direction that we're traveling as well. One other thing I'd like to discuss in here is the idea of direction. It's so important to know that with acceleration, it's always talking about a straight line. But, well, what about things like curves that we see over here, or circles like merry-go-rounds, Ferris wheels, the wheels on your bike, all those things that go round and round and round? Well, the thing is, if it's changing direction, you are rapidly changing your velocity as well, and your acceleration, because these are all different vectors and directions. And so the thought is that if I am changing my direction, I am very quickly going from a zero velocity to whatever speed I'm traveling. And so in theory, I'm actually accelerating the entire time, even if I'm going the same velocity the entire time. Okay, so even if I'm going the same exact thing, the same exact velocity or speed, since I am changing direction, I am constantly accelerating because I'm changing my velocity as well. So in that thought, whenever I'm going in a circle, I'm always increasing in my speed, even though I'm going at the same direction, or same speed the entire time. And so that wraps up our discussion on acceleration, what it is. Here's a quick cheat sheet to help you out with some formulas, a sample unit, and the definition of it. Our next video, lesson 2.2, after you're done and you finish your example problems that you write and you're still stuck, I have a walkthrough that we're doing in Forces 2, lesson 2.2. With that, I leave you back to your lab, and I wish you the best of luck in the rest of that. Have a good day.